Hello guys, what's up? We are back again with another question. And today our question is minimum length of anagram concatenation. This is the question of today's contest. And we need to. So let us see how we can solve it. So let us first understand the question. So in this question, we are given a string S, which is known to be concatenation of anagrams of some string T. Return the minimum possible length of string T. Anagram is formed by rearranging the letters of a string. For example, A, B, A, B, A, and so on. Okay. Uh, Now, first, let us understand the problem, what it says. So, we are given a string S, and they are saying that it is formed of concatenations of some anagram strings. So there must have been a string. There must have been a string, let's say T, okay, which is reordered, which is rearranged and put like this, and like this. So what we need to find? We need to find the minimum possible length of that string T. Now we can consider that there might be more than one strings. So we need to find the minimum possible length of the string T, which does what? Which satisfies the condition that every adjacent or every T length, the string S should be made up of T length strings, which are anagrams of that string. Okay, so anagram, a parent string and their anagrams will have the same length. So let us see, for example, in this question, if I consider AB as my parent string, then clearly I can see that AB and BA, two lengths are of panagram. Now I cannot have minimum. I can't take A as my string, because then this also had to be a because we need to have anagrams adjacent to each other. For example, in this CDEF, so we can have C, we can not have C as an anagram because it is not repeating. C, D also, E also, F also. So we can't have like that. Now, a lot of solutions are based on GCD. Yes, a lot of solutions are based on GCD in this. So this was a drawback, you can say, of this problem. But GCD solution fails in many situations. For example, if I have a string like, for example, if I have a string like A, and let's say D, then the GCD solution won't work. In GCD solution, what they are doing is that they are calculating the frequency, and then they are taking their GCDs so that they can evenly distribute. They know that what is the minimum frequency, and then they can evenly distribute among them, and then they are finding the length by simply dividing the total length by the GCD. So total length by GCD, and through GCD they are getting the minimum which can happen. So by this formula they are trying to derive, but this holds true. This holds true when you are allowed to rearrange. You are allowed to rearrange the string. But in this case, we are not allowed. In this case, we are not allowed to rearrange the string. Hence, a GCD method will fail. And even in hints, if we see, they are saying that go by the consider the the fact that the string length of anagram, the anagram string length will be a factor of total length, because it is only repeated. Just a second, I will remove this. Because it is repeated. Okay, so we are going to use that fact to our advantage. That, let us say I consider that my string anagram string length is of 2. Then I am sure that there will be two length strings up till will only those will comprise the whole string my s. Okay. So yeah, what I'm trying to say is that the n, or you can say that s dot length is has to be a multiple of the my anagram string. So I will try all possible ways and find it out. Like I know that if n percentage I will try looping from n to I. If n percentage I is equals to, just a second. Yes. If n percentage I is equals to 0, that means it is possible. It might be possible that I can try it for the anagram. So I will check this condition and call for a solve function. Now, how to check? How to check if these I length, I consider that two length strings are anagrams. So how I can check that? So clearly I can use frequency method for this, because if two strings are anagrams, then they will have the same character frequency, only they will be rearranged. So what I will first do, I will find out the first k letters. I will find out the first k letters which I am considering as my length of the anagram string frequency, and then I will compare it with the rest. So if anywhere I get that their frequencies are not matching, then I will then and there return false. Now the complexity strains are also very tough in this problem, as uh, if you will use here map, either ordered or unordered, this won't. So you make sure that you use here 26 character. And if you are trying to extract characters, if you are trying to extract characters using STL functions like substring, then also it might give a memory limit exceeded or time limit exceeded. So you have to optimize that part in this question. And yes, so I will first go through and find out the character frequency of first k letters. Then I will check for the rest of the string. So every time I will take k characters and find their frequency and compare it with the you can say this parent array or look up to array. And if they are not equal, then I will return a false. So yeah, guys, this was all from this question. Thank you so much, guys. Just in case you like the video, like the question, make sure to hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.